Yeah, so we know that everything is made of particles, matter is made of particles, and mole of a substance is the amount that has Avogadro's number of particles. There's a reason why Avogadro's number is so important. There are two symbols that we use for Avogadro's number. In A2, we will use the symbol L, but for now, we can use the symbol Na. And this is 6.02 into 10 power 23. It's a pretty big number. And there's a reason why it is the way it is, which we'll study when we do A2 electrochemistry. वहां से clear हो जाएगा कि क्यों ये especially ये number क्यों है. But we are just saying that अगर किसी भी चीज में इतने particles आ जाएं, so that will be a group, a stack of things called one mole. So a mole is kind of like a way of figuring out or counting the particles. और बस हम उनको ग्रुप कर देते हैं और उनका नाम दे देते हैं मोल का. We do that all the time with other things. For example, if you take on things और आपने 1, 2, 3, 4 count करते जाओ and you get to 1000 of those things, तो हम उसको बोल देते हैं कि ये उसका 1000 of that है. That's a group. 1000 is a group of things that count to this number. A million is a group of things that count to this number. A trillion is a group of things that count to this number. And there are smaller numbers as well. A dozen is a group of things that is just 12. And that is a unit that we have. We can have 2 dozens, which means 2 times 12. We can have half a dozen, which means 6. We can have 500,000, which means half of this. We can have 3/4 of a trillion, which is 3/4 of this. So we just use a big number and we group things in there. And then we are like, कि इसके multiples को हम ले लेंगे. इस 2 trillion, 17 trillion, 20 trillion जी US की economy है. ठीक है. 8 billion लोग हैं. तो billion is a number which is there. And 8 is just telling us कि 8 times a billion is that big number. It helps us communicate things. Just like that, mole helps us communicate the idea of having things in this amount. Okay. Just give me a minute. Yeah, so a mole is basically this many things in that amount. So that's all we have. हमने उसको group कर दिया in this case. All right, and we can have half a mole, we can have 3 moles, we can have 10 moles. All of that is just telling us that half a mole means that half of that number. 2 moles means 2 times that number. Now here's the thing. All of that is good. Count कैसे करोगे? We can count a dozen. 1, 2, 3, 4, 5, 6, all the way to 12. We can count to 1,000. With enough people, we can count to a trillion or a billion. We can't count to this number. It's a huge number. This number is bigger than all the humans that were ever there or that will probably ever be in the world. This is such a big number. Count नहीं कर सकते हम. But we can somehow calculate it. So we say, okay, count नहीं कर सकते ना? No worries. You know that 1 mole is 6.02 into 10 power 23 of those things. Sure. But it is also something else. It is equal to MR of that thing. MR तो calculate कर सकते हैं ना हर चीज का. You have sodium, that's 23, that's the AR. You have carbon dioxide, that's 44. Easy. बहुत आसान है calculate करना. MR. कर सकते हैं. सिर्फ एक काम करो. उस MR के साथ grams लगा दो. And there you have it. There you have 1 mole. So how much is 1 mole of anything? Just take its MR, put grams next to it, and that's how much is a mole. That makes it so convenient to work with. Ethanol hai. All you need to do is calculate the MR. 46. 46 gram is 1 mole. Water hai. Calculate the MR. 18. 18 grams is 1 mole. Calcium carbonate, MR, 100. 100 grams is 1 mole. So convenient. All you need to do is calculate the MR, which we can, and then take that many grams. Okay. Fair enough. How about gases? Gases are easily stored in cylinders, in gas syringes, और gases की volume calculate करना आसान है. Gases का mass calculate करना थोड़ा सा tedious process है. तो Avogadro's law वो भी हमारे लिए आसान बना देता है. Avogadro's law says that 1 mole of any gas will take 24 dm cube at room temperature and pressure. आप उसका टेम्परेचर फिक्स कर दो, आप उसका प्रेशर फिक्स कर दो, आप उसके नंबर ऑफ पार्टिकल्स फिक्स कर दो, तो पीछे जो भी चीज रहेगी वो वॉल्यूम है, वो ऑटोमेटिकली फिक्स हो जाएगी. सो वो कहता है कि वो 24 डीएम क्यूब पे फिक्स होगी. सो नाउ वी हैव अ वेरी सिंपल टेक्निक. वी नो व्हाट अ मोल इज. आपने काउंट करना है, इट्स दिस मच. आपने वे करना है, जस्ट टेक द एमआर, टेक दैट मेनी ग्राम्स, वो 1 मोल हो गया. और आपको अगर पता है कि वो गैस है, रूम टेम्परेचर प्रेशर पे ले आओ उसे, एंड 24 डीएम क्यूब में 1 मोल होगा. सो 48 में 2 मोल होगा, 12 में हाफ मोल होगा. Such a convenient thing. Okay, so let's try that. Let's do mole conversion. So here's what you have to do. Let's say there's a question. What is the mass of 3 mole carbon dioxide? So here's what you do. You're like, okay, what's the mass of 1 mole? 1 mole of carbon dioxide is 44 grams. All you need to do is take the MR, that many grams. Okay. You need 3 moles. So that is X, cross multiply. X is going to be 44 times 3 grams. That's your answer. 132 aega shayad. Okay, here's another question. What is the volume of 20 gram calcium carbonate when boiled? या 20 gram calcium carbonate vapor at room temperature and pressure. अब ये कैसे कैलकुलेट करेंगे? मैस तो कैलकुलेट कर सकते हैं, वॉल्यूम कैसे कैलकुलेट करेंगे गिवन दैट वी हैव द मैस? मैस पता है, वॉल्यूम नहीं पता है, कैसे करेंगे? कोई मसला नहीं है. मोल गिव्स अस द वे. ऑल यू नीड टू डू इज, देखो 1 मोल कितना होता है? So calcium carbonate, 1 mole will be 100 grams because its MR is 100 grams. Okay. And when it's vaporized, it's a gas. So that is 24 dm cube. Okay. How much mass do you have? 20. What will its volume be? X. Cross multiply. So 100x is 24 times 20. X is going to be 24 times 20, whatever that is, divided by 100. Simplify कर लेंगे, we'll get 4.8 dm cube. There you go. We are able to go directly from volume to mass. We don't need to do any formulas. Mass over MR. ठीक है, the formula is there. You can always take the formula. But this is a pretty straightforward thing. Ratio method will help you every single time. Let's make it a little more complicated. Let's do the actual past paper questions. So here we have a question. In this question, you don't have simple mole conversion. What you do have is mass of one thing, or moles of one thing, and moles of the other. And chemical equations show us the way to compare them. So if you look at this, every chemical equation has some numbers in there. These numbers are basically there as ratios of moles. So ये हमें क्या कह रही है ये equation? It's saying 2 moles of sodium and 2 moles of hydrogen, 2 moles of water produce 2 moles of sodium hydroxide and 1 mole of hydrogen gas. So let me just focus on sodium and hydrogen gas. Why? Because I have excess water. The word excess is important. It simply tells me that you can ignore that thing for now because the amount of that is not limited. वो बहुत ज्यादा है, वो इतना ज्यादा है कि आपका सारा reaction उस पे depend ही नहीं करता है. It depends on the other thing. Its concentration is, you can take that to be a constant. So let me just focus on sodium and hydrogen. In sodium, I have 2 moles. In hydrogen, I have 1 mole. That shows a relation. 2 moles of sodium produce 1 mole of that. So 0.4 mole of sodium will produce X moles of that. Cross multiply, and X will come out to be 0.2 moles. Clear? Right?
Yes, sir.
Can you calculate any of these 3 questions? कोई एक इनमें से पिक करके सॉल्व करो.
Sir, I did question number 3.
Okay. So
0.01.
0.01. So you're comparing H2S with HCl. 6 produces 3, so 0.02 will produce half of that, 0.01. Good. Now, let's move on to the limiting reactant. Limiting reactant kya hota hai? Limiting reactant is the one thing that produces less product. Limiting reactant produces less product. So there are 2 ways of figuring this out. One is by comparing the reactants. So agar main dekhun ki one of this needs 6 of that, so 1:6. So just pick any one of them. So main pehle isko pick kar leta hu. So 0.1 will need X of that. So X will meet 0.6. So the question is, do you have it or do you need more? Do you have this much H2SO4? We don't.
We don't, yeah.
We don't. If you have it, that means the thing is in excess. If you need more, that means the thing is limiting. It will limit how much of the reaction occurs. You don't have it, that means it is the limiting reactant. The limiting reactant is going to be H2SO4. So that is one approach. The other approach is called least product method. Again, I've just made all of this up, so you won't find it in the book. The least product method says you pick any one of the product. So मैं water pick कर लेता हूँ. Okay. So one of this produces 6 of water. So 0.1 will produce X of water. So X comes out to be 0.6 mole. So if I use all of this, I will be able to produce 0.6 moles. Okay. How about water? 6 of H2SO4 will produce 6 of water. So 0.5 of H2SO4 will produce, obviously, 0.5. Which one's bigger? This one? That's in excess. The least product method says the one that produces the least amount, that's the limiting reactant.
So we are comparing H2SO4 with like the product.
We are picking any one product and we're picking each reactant one after another. और हम उनको compare करते हैं उस product के साथ.
So I could also do like 6:2.
You could. So you'll do 1:2 and 6:2, और दोनों को देखोगे which one produces the least amount. The one that produces the least amount, that's your limiting product. Or limiting reactant, sorry. Similarly, another method is you compare reactant to reactant. ठीक है? So जो कम होता है वो limiting होता है. So that was the first method. That's the method that you're used to doing in O levels. The other method is least product method. You pick any one product and you use it. So can you use it to figure out B or C, any one of these?
I'm sorry, I did the first one.
Okay. B
And
part.
yeah, ASCl3 is the limiting reactant.
So which method did you use?
The least and product wala.
Okay, least product method. Okay, so which product did you use?
AS06, AS406.
Okay, so for ASCl3, 4 gives 1, so 0.2 should give X. So X will come out to be 0.05, right?
Yep.
Yep. And in that case, 6 will give 1. So 0.25 should give X. So X comes out to be 0.25 over 6, which is 0.04 something.
Oh, wait. 8 minutes. I know what I did wrong. Yeah.
417. So clearly, this is the limiting reactant.
Yes.
Okay. Now over here, you could use the reactant comparison as well. You could compare ASCl3 with H2O. You could be like, okay, 4 needs 6, so 0.2 will need X. Cross multiply 4x equal to 0.12, X is equal to 0.03. Do you have it or do you need it? You don't have it, right? We need more, right?
Yeah.
So that means it is the limiting reactant. You could do that here. So either method will work. The least product method will also work. And the product comparison will also work. Sorry, reactant comparison will also work. But there are cases where the reactant comparison is a little too difficult or long. For example, in this case, you have 3 reactants and you want to compare each one to figure out what the product is going to be or which one is the limiting reactant. So for that, the reactant comparison method can be a little daunting or confusing. The least product method will work. So try to solve this question through the least product method and tell me which one is the limiting reactant.
Sodium chloride, 0.05.
Good. So which product did you pick?
And it sodium sulfate.
Sodium sulfate. So 2:1, right?
Yeah.
Yeah. So in the case of sodium chloride, it will produce 0.05. For 0.15 of this, it will produce 0.15. And for 0.2 of this, it will produce 0.10. So clearly, this is the limiting reactant. So you can see that least product method helps us solve the limiting reactant problem right away. Why is this important? Because once you run out of the limiting reactant, your reaction stops. After that, the reaction doesn't proceed and you're just left with whatever is left over. Okay. And it's very important in many questions and topics later on that you will see that knowing what is used up and what is left over, it is super important. And we can use the ratio method for that as well. We'll get to that when we do. And here you go. Now let's try to do this question. Consider the combustion of butane. 10 grams of butane react exactly with that much oxygen to produce 30.28 grams of carbon dioxide. What mass of water was produced? Now in this question, the key point is that 10 grams of butane have reacted, 35.78 grams of oxygen have reacted. Maybe they're both exactly the amounts that we need. Maybe one of them is in excess. And we can solve this question by first figuring out what is in excess and then using that to figure out what water is. Because remember, the thing that is excess, we ignore that. The thing that is in limiting, we take that value and we use that to compare with whatever the product is going to be. That is one option. But a smarter option would be the products will always be in the same ratios. So ignore butane, ignore oxygen, just focus on the product. You already have one. You know that 8 carbon dioxide produces 10 water, right? Now, can we use moles to figure out what mass of water is produced? Now, let me show you this method. Again, pay attention. The equation is telling me when 8 moles of carbon dioxide is produced, 10 moles of water is made. Okay, 8 moles of carbon dioxide, 10 moles of water. What is mass of 1 mole of carbon dioxide? Just take the MR in grams. So 1 mole of carbon dioxide is 44. What is the mass of 1 mole of water? 18 MR. So basically, I'm saying 8 moles of carbon dioxide, which is basically 8 times 44 grams of carbon dioxide, produces 10 moles of water, which is 10 times 18 grams of water. Because 1 mole is 18 grams, so 10 moles is 10 times 18. I have a straightforward comparison right away. So 30.28 will produce X, cross multiply, and you'll get your answer.
Sir, why did you multiply 8 with 44?
So first of all, you have to understand what the equation is telling me. The equation is telling me 8 moles of carbon dioxide produce 10 moles of water. So as long as I understand the relation between moles, I can use the idea that 1 mole is MR grams to compare to mass. I can use mass over MR, right? I can use volume over 24 to do that. I can use number of particles over 6.02 in 10 power 23 to do that. Or another way I can do that is just know what 1 mole is. 8 mole carbon dioxide produces 10 mole water. What is the mass of 8 moles? 8 times 44. What is the mass of 10 water? 10 times 1/8. So basically, here's the method. You copy the part from the equation, whatever is relevant, and then instead of writing the formula or that thing, just put the value of 1 mole. And it works like a charm every single time. Let me show you another one. Consider a reaction of sodium with oxygen. You have the equation. How much sodium reacts exactly with 3.2 gram oxygen? Now, this question is a little vague. In CIEs, they don't say how much. They will mention what mass or what volume. They will mention all of that. But let's say we are considering mass here. So what mass of sodium reacts with this? Okay. So here's what you do. You copy the part that's sodium and oxygen, the relevant parts. So 4 Na and O2. Okay. So this is telling me 4 mole sodium reacts with 1 mole oxygen. Okay. What is the mass of 4 mole? 4 times 23. Just put the value of 1 mole. That's the thing. In the first line, you're writing from the, you're copying from the equation. In the second line, you're putting value of 1 mole. What is 1 mole of oxygen? It is 32 grams. So 4 times 23 grams needs 1 times 32 grams. दोनों के mass आ गए. So 3.2 gram oxygen will need X. Cross multiply, you will simply get your answers. 4 times 23 times 3.2 is equal to 32X. So bring this 32 here and you will get your answer. I think 9.2 आता है.
Uh, 1.1.
1.1. Okay, so that might be the answer. Are you sure?
Oh, wait. Sorry, I took 3.2 as sodium ka mass.
Oh, okay.
Yep, 9.2.
There you go. That's the answer. Okay, and then they're saying what mass of sodium oxide is produced. You just take that thing. So what mass of sodium oxide? You simply take sodium oxide part and take the other limiting reactant. Right now they're both equal amounts, so matlab wo limiting koi bhi ho sakta hai. But you can take oxygen because it's given to us. So 2Na2O, just copy the part. Now put the values of 1 mole, so 32 grams. And for this one, it's going to be 46 plus 16. I think it's 62 grams times 2. And 3.2 will produce X. So I think X will be 1.2, 1.4. Or 1.24. Can you confirm?
Yeah.
$12.4.
Yep.
There you go. Do this question yourself.
Sir, part A ka answer is 52 grams, and like part B is 44 grams.
Yes, that is correct.
I
No
just
way to
have a
lie.
question.
Yeah.
I
I think
use,
there's something wrong with the values that you gave me.
is there, wait,
Yeah, I guess.
should I do it again?
Yeah, sure. Try it out. Let me solve it with you. So for butane, we need to figure out the MR first. So it is 4 times 12 for carbon and 10 times 1 for hydrogen. So that is 58 grams. So it tells me 2C4H10 13 O2. So that means 2 times 58 of butane requires 13 times 32 of oxygen. So 10 will need X. Cross multiply. X will come out to be 35.8 or 35.9 grams. Did you get that?
I took the wrong mass for butane.
Okay. It's okay.
Yeah.
You can fix all these issues with practice. But as long as you understand the principle behind it, that's fine. Did you solve the next part?
Not yet. Is it 1?
I'm sorry, what?
Is the answer 1?
I don't think so. It won't be 1. It is, I solved this here, 30.3. Let's do it. So 2C4H10. So I copy that part, and the carbon dioxide part produces 8 CO2. So 2 times 58 produces 8 times 44. Again, these are the MR values. You can easily calculate them. So 10 of this produces X of that. So 2 times 58 times X equals to 8 into 44 into 10. So there you go. There you go. So I'm getting 30.3 grams. Okay, here's the thing. Now imagine if I had told you that when we did this experiment, we only got 20 grams of carbon dioxide. Then we can use that idea to figure out percentage yield. It's a really useful concept. What we do is we say, okay, if this reaction happened 100%, then we would get 30.3 grams, this value. This value is called the theoretical value. But when we actually did the experiment, we only got this one. So that means this one is called practical value. So what percentage is that? So we'll be like, okay, 100% is 30.3, 20 grams is X. And we solve that, X will obviously give us the percentage yield. That's what this is called. So X, sorry. Why is it not? Okay, so X, oh God, something wrong. Yeah, X is, oh God, yeah. So X is going to be 20 over 100 times 30.3. Oh, sorry, 20 over 30.3 times 100. And this is called percentage yield. Basically, If the reaction happened 100% successfully, then whatever calculated value is, you would expect that to happen. But for many, many different reasons and factors, that doesn't happen. So we get only a small amount of that, and that is what we know as percentage yield. Percentage yield is a very easy and convenient way for us to figure out which reaction is happening to what extent. Okay.
Sir, to how many significant figures do we give the answer to?
Final answer, I would suggest 3.
It's 66.2%.
66.2%. Okay, so that tells me that this reaction is 66% successful, or the yield is 66%. Okay.
Yes.
And there you go. That is a very useful technique. Now, of course, this method of comparing values of 1 mole goes beyond just mass. You can use it to figure out volume. मतलब अभी अगर वो हमें यहाँ पे कहता कि instead of mass of oxygen, what volume of oxygen will be produced, तो आपने simply यही करना था, 2C4H10 13O2, and instead of saying okay 2 times 58 grams and 13 times 32 grams, you could say 13 times 24 dm3, and there you go. You have suddenly compared mass to volume, because mole allows you to do that. That's the whole advantage of using moles. You can compare mass to volume, mass to particles, volume to mass, volume to number of moles, or anything you can compare with anything, as long as you're talking about pure substances. For impure substances, the method is slightly different, and I'll teach you that tomorrow. But for today, I'm going to send you 2 worksheets, and I want you to solve both of them. Okay?
Yeah. Thank you.
All right. Take care. See you in a
Have a-
while.
Okay, bye.